The distance from a point to a plane. The distance from a point P to a plane is the length of the line segment L from the point P to the point Q that is parallel to the normal vector n of the plane and intercepts the plane at Q. The point Q is called the foot of the perpendicular to the plane from the point P. So, foot of the perpendicular. Foot of the perpendicular. So if you think of the perpendicular like a leg, then this is the foot. 1, 2, 3, 4, 5 toes. Well, you get the idea. That is it's pretty horrifying, but I think I made my point. Okay, anyway, let's continue here. So just getting a fresh diagram over here. Suppose that we know P. So P is the point with coordinates P1, P2, P3. And we also know the vector n. So n is the vector n1, n2, n3. And we also know the equation of the plane. Let's call the plane pi, and let's say that it has equation, well, it needs to have equation n1x plus n2y plus n3z is equal to some constant d. Then it's pretty easy to find Q. In fact, we know that OQ is equal to, so if this is the origin here, over here, we know that OQ is equal to OP plus PQ. Moreover, we know that PQ is parallel to the normal vector n. In the diagram I've drawn, it's in the opposite direction, but that doesn't matter because n could also be pointing in the opposite direction. This is an arbitrary situation. So the point is that PQ is some multiple of n. So we have that OQ is equal to OP plus K times n, where K times n is equal to PQ. Now remember, the goal here is to find the length of PQ, which we can see here is equal to the absolute value of K times the length of n. So now all we got to do is find K. Alright, so OQ is equal to OP plus KN, which is equal to P1 plus K times N1, P2 plus K times N2, and P3 plus K times N3. And from this, we can immediately find K, because we know that Q is inside the plane pi. And hence, when x is equal to P1 plus Kn1, y is equal to P2 plus Kn2, and z is equal to P3 plus Kn3, this equation here should be true. And so from this, we get that n1 times P1 plus K times n1 plus n2 times P2 plus K times n2, and then for z it's n3 times P3 plus K times n3. Then this is equal to d. And throughout this equation, the only number that we don't know is K. We know all the other numbers. And hence, this is going to be a linear equation about K, so we can immediately solve and find K. And once we've found K, we can find the length of PQ, which is the distance of the point P from the plane pi.